Okay, welcome back. Good afternoon. Now, hopefully everyone got enough caffeine and some of those chocolate chip cookies to keep us going through the afternoon, the dreaded afternoon session. But real quick, sort of quickly talk about some of the things. We talked about the large umbrella of explicit instruction and everything that is involved in there. And the main aspect of direct instruction is the fact that the teacher is responsible for delivering that information, as well as some of the other design issues that go on. So what is it that some of you are doing currently in your schools that you think is directly aligned with what explicit instruction is, or certain characteristics of explicit instruction? Go ahead, table 13.
Our schools have encouraged us to divide our lesson into 3 parts and state in the opening what the students are learning based on the standards for that particular unit, and have the students even verbalize or be aware of what the standard is and connect it to what they're learning. So
good.
We are doing that in all of our classrooms now.
Standards used to be top secret for teachers. You know, we were the only ones that had knew what the standards were, and I think that's very important. People, you as well, adults, want to know what it is you're going to learn. Therefore, that's something that kids will do better if you tell them what it is you're going to learn. So yeah, don't let it be a secret what it is you're trying to teach. And I like the idea that Georgia, that's the model lesson where they have the opening, the body, is that what you used, and then the work session. And that's where this level of explicitness is going to occur in that body and that work session. Good. Anything else? Table 8.
We also are allowed to do mini lessons, which could be considered somewhat of like a presentation or a review of a lesson that was previously covered that we needed to kind of touch up on for that.
Excellent. That's another thing I want to highlight is, you know, you have 45 minutes of instruction or 90 minutes of instruction. Don't feel you have to have one lesson for that whole period, but that you can do these mini lessons or these modules where you're touching or revisiting something, where you have a condensed version of the opening, the body, and then the work session in these mini lessons. And that is a very good way to continually review things from earlier in the year, or review something that was on a test. Good. Table number 5.
We use the Frayer model for our
excellent.
vocabulary, so that they have a
structure,
vocabulary structure, and so that they have an example, a non-example, the term in their language and the term in correct.
Excellent. Now,
math
she said the Frayer model. I don't know if everyone's familiar with that, but it's simply a structure to work with vocabulary where you have some examples and non-examples. Now remember, not everything has a non-example. But now, here's a question for you. Mm-hmm. You use that in math class for math vocabulary.
Yes.
Do you use that in other classes, the same Frayer model?
Not currently.
Yeah. So that's with that Frayer model specific to math, but where you begin to try to look across is when you start looking at strategies that can be taught, the same principles taught in math as well as in other areas, such as concept maps. If you can start using concept maps sort of across different content areas, kids then are recognizing the structure or the strategy. And that goes back to the slide that said kids need to know what it is they're going to learn and how they're going to learn it. And in this case, as soon as you talk about math vocabulary, the kids in your school are going to immediately recognize what? Frayer model is what they're going to use in the parts of it. So that's excellent. Good. And even like the fact better that you're taking specific time about math vocabulary to talk about it and do some examples. Anybody else before we move on? I want to bring up a sidebar conversation that I had with table number 7, and I didn't get your name. Sherry had asked a question about manipulatives, and in Georgia, there's a huge emphasis to use manipulatives, concrete objects, and so forth. And I haven't maybe specifically made this statement, but we talked about the model, and kids should not necessarily be taking notes when you're trying to show some demonstration. The same principle can hold true with the first time that you're going to model something with concrete objects. That if they have the manipulatives in front of them, then those manipulatives act as a what? Could act as a distractor. So some kids, now it's not all, this is highly dependent upon your kids. Some kids, it is better that the manipulatives are set aside initially where you model it, and hopefully you can have them somewhere where they can see it, or on an overhead transparency or something along those lines where they can see the model. Then once you've modeled it, then they get theirs, and it would be even more strategic if they then tried to do the exact same problem that you just modeled versus another problem. So the explicitness is both with any type of computation or procedure that you're trying to demonstrate, as well as concrete manipulatives, that anything the kids have in front of them could be distracting or overloading them. And with kids that struggle, we sort of separate out and then put back together. So that's something I wanted to bring up as far as the use of manipulatives as well. Anything else? Anybody else struck them? The becoming more explicit is something that may not necessarily be built into materials that you're using, and it's hard to determine what level of explicitness all kids need. And that's where the fine art of teaching. But the main principle with explicit instruction is that you're providing the students very, very explicit step-by-step demonstrations, examples, and models of what it is you want them to do. All right, excellent. Any other comments from the beginning? Yes, ma'am. Table number 9.
Something that we're doing at our school is, we call it Power Train. And what it is during our ELT, or our extended learning time in the morning, all teachers that have students at that time are reviewing math facts. And right now we're doing fractions.
Oh, good. As a school-wide initiative.
School-wide.
Now we're going to talk about scaffolding instruction, and right there is what they have is a scaffold. The first level is that they have built in time, and I really encourage you to take a look at the time that you have set in your day and start looking at ways to maximize learning. And what I also like about it is it's a school-wide, because a lot of times we sort of get into this, the kids with learning disabilities, it's these kids that are struggling that need the extra opportunities, but actually all kids can benefit from those type of activities. So I think that's an excellent way, sort of bringing another level of explicitness down to the students. Good. Anything from back there? Don't be shy. Okay. All right. Good. Now we're going to move in a couple things here, and we've already talked about this. Considerations as we move to be more explicit in nature. Number one, it does require some professional development on the part of the teachers. We've sort of really got into general explicitness and what that means. The next level is actually sitting down with your math teachers, if possible, and begin to look at the various concepts and ideas and coming up with ways to make them more explicit. And then the other thing is teachers are resistant to change, okay? All right, I know that. We all know that. Change, if you've been a teacher long enough, you say, well, it's a merry-go-round. You do it there, wait 10 years, it'll come back, it'll be a different name, packaged differently. You know, this whole differentiated instruction, it's a new word we had to make up so that people can write new books about differentiated instruction. What it is really doing what you need to do for kids that are struggling. So it's just something that you can't just expect to happen overnight. And as you go back, instead of looking at everything across the course of the year, pick something that's coming up and begin to look at it, and how can I make this a little more explicit for kids? Work on getting examples. That's one thing I know, that if you don't have a textbook, and even if you do have a textbook, there's usually not enough examples for the kids, and that's something that can be worked out. So it's something that it no longer is it sort of a choice kind of thing about what instructional approach that you want to follow. It really needs to be about the students and the performance of those kids, and that kids that are naive, struggling, or kids with learning disabilities, when you're trying to figure out something to do differently with them, we need to err on the side of being more explicit in nature to help them move to that next level. All right. The next thing that we're going to get into is instructional scaffolding. And this is something that is also specifically referenced in the literature on effective instruction, as well as in the National Math Panel report. And basically, although there's some definitions that I'm going to talk about, scaffolding is anything that a teacher does to support learning or help kids learn something. And it can be anything. It can be a teacher standing beside a student, and you know how this goes. You're teaching them a complex, and you stand beside them, and they start to write something down, and they kind of look at you, and you go. and then they cross out and they go back to doing something else, that's a support. You're prompting them. So we all are doing this. Now, what we're going to look at are three ways that we can do this a little bit better. But basically, scaffolding, a technical definition, it's a process in which teacher adds support for students to help them learn, all right? And this can be anything from verbal prompts to more examples to explicit instruction to anything that will help the students learn. Guided notes, concept map, those are all levels of what fall under scaffolded instruction. The best way to describe or picture what scaffolded instruction is to think about a large building in the Atlanta skyline that is going to be painted. All right? Where do they usually start painting? The top, right? And what do? They paint from the top and go down. Now, why do they paint start at the top? We'll see how. That's what they could start at the bottom, but when they start at the top, anything that drips down is going to get painted over instead of having to go back and paint. And they're usually on a very large scaffold. And as they move down, in other words, as they paint down, what happens to the scaffold? It's taken away. Now take that picture and think of the student. The first initial instruction you're providing a student. You want to be there with your support the whole way. As the student begins to learn and become more confident, you must do what? Fade away. All right, scaffolding. So we have the tall building is the student in the initial instruction. And when they're initially learning something, they need to have all the support they can have. But as the student becomes more confident, we must fade that support away. And special education teachers, they tend to provide a little bit too much support because we want everything possible to have the students successful. And then when they leave the special ed classroom, what happens a lot of times? It's not there. Regular ed classroom teachers, they tend to not provide enough support, and for various reasons, 30 in the class, 28 in the classroom. But what we don't do a good job of is slowly and strategically fading that support away. We either do it too fast or we don't do it enough. So within this instructional scaffolding, there's no exact moment when support should be applied or taken away. It's very dependent on the students and how they're progressing. But the big thing I want to emphasize is it is temporary. It has to be temporary. We want to get our kids to be self-regulated, independent learners. In other words, doing it on their own. And we must fade our support away. And within this, we're sort of looking at reducing the extraneous, irrelevant information, providing very explicit instruction, trying to elaborate, help the kids elaborate. And that's really a key word here is that when we learn something, we are basically taking new information and making it fit our construct or elaborating upon it, trying to make sense of it. And we want to do this all the way down to where the students can eventually do it on their own. Now, probably one of the funniest, or maybe not the funniest, but one interesting scaffold that I ran into is how many of you in your classrooms have some poster up on the wall that says, you know, order of operations or the trig functions or what, commutative property, associative, we probably all have something on there, right? That is a scaffold. Why did we put that up there? Pardon me? For students can refer to it. It's a support. And our purpose is, well, if they have a problem with it, they can look up there and help them or refer. Well, I was in North Carolina. We were doing our end of grade tests or course tests, and you can't test your own kids. So I went to another room, and I was in there, and several of the kids, they kept looking up during the test. And finally I said, what are you looking at? Oh, there was a poster up there that would help me answer this question. There's an example of a support provided and taken away immediately because when it's time for tests, what do we have to do? Take everything away. Now, I'm not saying don't put up posters, but what I'm saying is we need to get the kids to a point where they don't have to use the posters. So that's something that we need to keep in mind. Use the posters. I sort of like to rotate the posters. Initially, you're going to learn something, so the new poster goes up here. As you progress, it moves over to this side of the room, and you slowly put it to the back of the room where it's now initially up front, a little farther over to the left, and then it's sort of out of sight in the back of the room, and you slowly faded it. So that's a support. And whatever support we have, we must eventually fade it away. Now, within this sort of instructional scaffolding strategies, you hear a lot about strategy instruction today, and that is a support. The biggest thing with any strategy or task or steps is that they must be taught those steps prior to trying to apply them at the same time of learning a math concept. And that's where you have to sort of make the decision, pay now or pay later. Taking the time to teach the strategies will then provide structure later on in the year. But scaffolding really, the broad definition is we do it on a day-to-day basis. Most of us probably wouldn't even recognize that it is scaffolding because it's what we do to help kids progress forward. And it can be used with any age group, any academic tasks, and math really lends itself to scaffolding because of the nature of math. Now, the big focus here with scaffolding is activating background knowledge, all right? And this is something that, comprehension, everybody, that is a word that is used in reading, right? Comprehension. When a kid solves a math problem, that's demonstrating comprehension of a math problem. Does that make sense? And it's something we need to use more in math. We sort of say proficiency, but when a child is able to take a math problem, apply some logical sequences, follow math concepts to get an answer, they have basically comprehended what it is you're trying to teach. And what's important is trying to activate background knowledge. And this is probably best illustrated with a non-example than it is with an example. You learned this last year. I know you did. So remember that. Now we're going to do this. All right? That is not a good way to activate prior knowledge or background knowledge. But it's something that you need to sort of be aware of. But really what you end up being with scaffolding is you're in a way being a coach, initially getting them to where they're independent in the end. Now, there are 3 types of scaffolding, and we're going to get into each of these. And I'm going to model a good example of scaffolding with the word problem. Now, don't think these are clear-cut black and white, and don't think you can only scaffold content and not task. There's a lot of overlap between the 3. But with content scaffolding, the main premise here is to try to start off instruction that is not distracting, all right? In other words, things that become too difficult or unfamiliar, we're trying to boil it down to where it's not distracting to the student. And we want to focus on the concept or skill being taught. And this is where the math panel report was talking about real-world context versus not real-world context. And that real world, and if you think back to word problems in your book, they're very what? Wordy, distracting, full of a lot of different things, when really what you're trying to boil down is the child able to apply a concept or a skill to solve a problem. So with content scaffolding, what you're going to do is try to strip away all that irrelevant, distracting information. This is especially relevant for kids with learning disabilities because they have problems with what? Reading. Try to use familiar, highly interesting content. Now, sometimes that's easier said than done. Start easy and work to the more difficult problem. This is how most math books start off. The examples that they give for you to use are usually the simplest occurrence of what you're trying to teach. Then, when are the more complicated problems introduced? In independent practice. So we need to start easy and then become more difficult. Now, here is an example. Word problems. Now, most books are not set up in this fashion, but I took this word problem out of a very popular 8th grade math book. I just copied it right out. Robert planted an oak seedling. It grew 10 inches the first year. Every year after it, it grew 1.25 inches. How tall was the oak tree after 9 years? Now, that's not too bad. Most of the time, it's like at 4:40 on January 7th, Robert planted a tree. He was 17 years old at the time. His birthday was on January 15th. All right? It was sunny, 88 degrees. You know, kind of one of those questions. Lots of information, and then in the end, who's driving the bus? Right? So with a content scaffolding, basically, you're going to redo the problem and take out all the irrelevant information. Now, I did 3 things in writing this problem. The first thing was I took out irrelevant information. Robert planted the oak seedling is irrelevant to the concept of this problem. I then did 2 other things. I took out the what? The fraction. All right? That is distracting. All right? Because as soon as the kids see a fraction, what are they going to do? Yeah, I don't want to do it. Now, what was the other thing that I did? Now, there's several strategies that are out there that are based on this, but I basically took the question and I gave the answer. Now, one of the reasons I really like this is because, number one, it's not that difficult to do. And what I have done now is instead of having a question, because as soon as kids see a question, they're going to want to try to do what? Answer it. Now we have a statement. And with this statement, we'll now relieve the kids from having to get an answer, and it will now allow us to have a discussion, comprehension-wise, regarding the problem. And this now allows us to really talk about how we set this problem. By the way, what do you think the most common answer is going to be if you quickly just look at that problem?
19.
How many of you thought it was 19? None of us. But this is going to allow you to then really get into discussing the process of solving that problem. It will allow you to write a number sentence. And now with the number sentence, they're not having to worry about the answer. They can focus all their cognitive energy on the process of setting up that number sentence. And that's something that most textbooks don't really do, is all the word problems are what? Questions. All right? That allows us to focus at the process. So that's something that's not too difficult to do, something you can do. And now from this point, you can then get into really having a discussion about what this problem means, what's the most tricky part of this problem. And the most tricky part of this problem is that it grows X number of inches in the first year and only X year after that. Now, what I want you to do right now, create a number sentence for that problem. Number sentence, an equation. It's not really an equation, but a number sentence for that problem. Number sentence.
No variables?
No variables. Number sentence.
Oh.
I'm taking you back even one level. We're going to get to the variables in a second, but we're working our way forward. All numbers for that word problem. Well, the number sentence is really what we want the students to be able to set up, is the number sentence. Now, usually at this point, there's a question, so we're trying to have the students set up a what? A variable or an equation in there. I've taken that out. All the numbers are there. So hopefully you had something, maybe you had 10 plus 1 plus 1 plus 1 8 times equals 18, or maybe you had 10 plus 1 times 8 equals 18, or something along those lines. There's a number sentence there, okay? Now, with your number sentence, I want you to rewrite it, and this time I want you to use all variables. Now, hang on. In math, if we're going to use a variable, what is the definition of variable? It's not X, Y, and Z, although that's how we represent it. It's a placeholder for a number. It could change, right? So now we're introducing more of an algebraic equation in. So I want you to substitute a variable in for each of those numbers. And when you put a variable, that means you must what? Label what the variable is.
Should have been G minus Y. Yeah.
Now I'm going to ask someone to share their variable expression here in a second. Now there's multiple different ways you could do this. I see this is sort of a task for us here. It's a little bit of a task here that we're doing here because we're really getting at the fundamentals of how we solve and set up a problem here. So our kids are even, they're even more confused possibly. But if we set up, if the kids were to set up, does everyone agree that that is a number sentence that represents that problem? Yes. If you have a kid that does that, that's a great opportunity to say, wow, is there another way that we can write repeating addition? And then that can get us to this, 1 times 8. Now, this is where it gets very tricky. The trickiest part of this problem is not necessarily the 10 inches, but it's the fact that right here, each one of these represents, 1 is the number of inches it's grew every year after the first. 8 is really the total number of years minus 1. Now that is what is the most tricky part of this problem, and now you can have a very nice open discussion about why that is y minus 1 or years minus 1. That goes back to the problem, okay? You see how we're breaking down this statement like a comprehension type of problem. Now doing this does take some time, but what we're getting at is the true essence of how you solve a problem. The variables here, right here, 10, what did you put for 10 there? X equals the first year growth or something along those lines, or A or whatever. And then what'd you put here for the 1? Number of inches it grew after a year, something along those lines. For the 8, how many of you put something as total number of years minus 1 or years after the first growth or something? That's how you're going to represent that in a variable problem, okay? And then what did you put here? Did you put a variable for the answer? T. Okay, so right now you're looking at an expression in front of you that has all variables, right? We have set that up with labels in why each aspect of that must hold true. Okay, now this is teaching problem solving, all right, which we don't do that much of. It's taking the words, putting into a number sentence, putting them into an expression. So now we have our expression. Now with that expression, I'd like you to use your expression to now solve this word problem. We used one word problem that had an answer. We set up a number sentence, and then we set up an expression with variables. From that point, we then used the same word problem format, but with different numbers, all right? And this is the other level of scaffolding, is that in most word problems in your book, the first word problem is about Robert planting a tree. Then the next word problem is about what? Going to the movies. The next one is about getting on an airplane. It's supposed to be motivating and interesting. What happens is it's distracting and disheartening to a lot of kids. So one way to get sort of approach word problems is to focus in on one word problem format and really take it from the basics into the next sort of level. And then again, now, after you've done that a couple of times, you then get into a problem where now they have to what? Get the answer. Okay, so the first two problems, I completely took computation out of the mix. You didn't even need to use a calculator. And because I wanted the kids to focus on the problem-solving aspect. Then we want to work into, now we've built confidence. hopefully, to where now, since they've seen a number sentence, they've seen the same word problem, now they're going to actually try to solve it. That's something that they have worked on with your support, and they can solve it. Anybody want to share their answer? 16 meters. Can't forget the labels. Now, that was a progression that was explicit and scaffolded. All right? And that's something with word problems. Everybody, word problems, they hate word problems. I can't do it. Well, might be in part because of the way we have to do the word problems. They have 4 word problems and they're all over the place. They have to do a different strategy. Now, this will take longer, of course, but students are going to have a much deeper understanding of what it is you're trying to get at. Now, this is something that can really be used to your benefit by slowly working your way to solving the problem. And that's sort of the essence of scaffolding. Now, we're going to revisit this problem, and I'm going to demonstrate sort of a task material scaffold as well. But any questions of what I just did on this progression? Because the purpose was not that what Robert planted and how high it grew for you. The purpose was to show you how you take a word problem that is traditionally taught as start to finish, number sentence, and so forth, and we take out the computation, take out the irrelevant information, and if you want to try to make it interesting to the kids, rewrite it with the kids' names in it. You know, that's really good. Then we start by examining the number sentence, and maybe you have to do 2 or 3 where you're just focusing on numbers. Then you do 2 or 3 where the answers are in there, but they're a little bit varied. You could also put, since you now have a variable expression, you could substitute an oak seedling grew X meters in the first year. Every year after it grew 2 meters. After 7 years, the oak tree was 16 meters tall. How tall, or how much did the oak seedling grow in the first year? Now you've got all these different things that can come off of one variable. Now, how does scaffolding look in a class? So let's say you're my group of 20 students, 28 students, and you know that there's going to be 10 that are ready to go after you show them the first example. Move them on. Then you have what's left. All right? So now I'm going to take them through a couple more examples, and then half of that group is ready to go, and now I'm down to my group of really struggling students here at group table 3, where I can take them through some more problems, okay? So that's a way that you go from whole group to small group, accelerate the kids that get it, provide the additional supports for the other kids, all right? It's part of differentiating instruction and scaffolding is management of the classroom. Yes. Table number 7.
Quick question about that. Then would you expect the table that or the group of students you're working with the longest, maybe they'll only complete 2 word problems for that class period, whereas the first group should complete 4 or whatever, 6.
Oh no, we just talked about changing an assignment, and what you said was, so maybe the group that I worked with only does 2 problems versus 10 for the other one. And I would my answer to that would be, yeah, I think that would be a very good idea to sort of differentiate that. What we found in the research on accommodations and so forth, teachers are much more willing to offer accommodations and support for tests and those types of things where homework isn't differentiated at all. Everybody gets 20 problems or 10 problems or whatever. But yes, I would say maybe they only do 2 or 3. As far as independent practice goes and homework, I believe much more in quality over quantity of the problems, okay? But that's something you're going to have to work out, and it also depends on how you use homework as part of your grading and all those types of things. But I think having them do a couple of problems is definitely a strategy.
So would you like plan ahead, because this is new to me, I think it's a great idea, plan ahead what problems you'd mark out on their homework sheet potentially?
Another issue that she's talking about here is all of this stuff has to take place prior to the class. And this is something that has to be set up, which means there needs to be teacher planning involved. And I know that you all have time to plan, right? I know, the logistics of doing that. But that's why start small and work your way in. But all of this differentiating, scaffolding, generally has to be thought about in advance. Table 1.
Then your assessment would would not be planned during the planning for this activity. Your assessment that you would grade them on or test them on would be done after you see how far they've gotten. So one teacher may have an assessment that covered more versus your class if you covered less.
So you're not using the same exact assessments? Is that what you're asking me?
It would be the same assessment, but say class A covered more material versus the second class, your assessment for your students may be different depending on that class?
Yeah, I think yes. If I'm understanding that you're teaching one class, they get farther along
Right.
than another class, your assessments may be broken up across a couple of different days
Right.
or something. Yes.
Okay.
Yes, table 8.
About something that you said when you were going through the definition of instructional scaffolding, and you said that it was temporary, only for temporary, and that the students should be able to do it on their own. And thinking about kids that have IEPs or some of the kids that need that little extra support from collaborative teachers in the classroom, how would something like this work? Because are you expecting that they can come up with that expression on their own, or would you provide and give that to
Excellent
them?
question. Excellent question. And what I didn't do with you, I made an assumption, and that was I put it up there and I said, give me a number sentence. All right? Breaking it down to another level was I would first model doing that number sentence with the kids 2 or 3 times before I had them try to do one on their own. Okay, I was sort of going with, is that what you're sort of getting at? So yeah, did I hear a co-teaching situation?
Like you said, we all teach exceptional ed, but when we have kids that are struggling that could eventually catch on, those kids that, really need that support from myself or from that other collaborative teacher, are you saying that they should eventually get to the point where they can do this by themselves?
Yes. I mean, that's our ultimate goal, is to have them do it by themselves. But if you're in a co-teaching situation, you know how I said I start with the whole group and then the kids, I sort of move them forward and I go back. If there's a co-teacher in the room, then you can even, subdivide it that way to where the co-teacher is providing some extra support as well. So if this is the group with the homework and they have homework, maybe another level of support is they do their first problem with the support of the teacher. Eventually, we want to try to get them to where they are doing it on their own. I mean, that's the ultimate goal, as much as possible. But very good questions, very good questions. Which I did not provide the model to this particular problem, but if you have kids that need to, you would model this several times, talking about it. And what's nice about this is usually we solve one word problem or we model a word problem, and then the next word problem is what? Very different. So kids are sort of, trying to elaborate onto something they're not real sure to begin with. So sticking with the same problems, going and scaffolding it. Now, I don't know how many times you need to model it, how many times they need to practice it. This group's homework may only be problems that already have the answers in, and they're having to write the number sentence before we get them to solve the problem. So there's various levels of scaffolding that can take place. Very good questions. Yes, ma'am. Table number 7.
What I do when I'm doing word problems, I didn't do it exactly like this where it's the same problem and you've changed the numbers. But what I have done is when we've done 4 or 5, and for homework that night, rather than do another word problem, they have to choose one and illustrate the problem. And I can really see where their thinking is screwed up when they are illustrations. So when they see this, it would give them a good feel. That first tree, the first year, would be 25 feet tall. That second year, it's going to be 9 or 5 and I guess it's 30, and then so forth. When they see that growth, that doesn't change that much between year 1 and 2, and 2 and 3, and 3 and 4, but yet the first year it grew tremendously.
And
Gives them a feel for what the next problem that they're going to work with.
And that's something I was going to talk about later, but we did this all at the abstract level. I could have very easily said, draw a picture. And then you draw the picture, or I could have taken it to the concrete level where you have blocks. Year 1, give me a model for year 1. It's going to be like this. Then what happens every year after? So there's all different extensions that you can go with this based on the kids and their abilities and their skills. But the bottom line, what I want you to take away from this is how you break down and remove things that are distracting to kids. Even though it's not really distracting to us, it may be distracting to those other kids. And what you're doing is this is how you build that confidence. That just for a kid to look at that problem and come up with a number sentence, that could be huge step to getting them to where they actually solve a problem. And I think that's a good idea. You know, model 5 problems, have some guided practice with 5 problems, send them home and have them redo the same 5 problems. Okay? That's all support and so forth. But very good questions, very good. So now at this point, we have our number sentence, and now we come back to the more complex problem. And this is what I want to emphasize here is you must take the kids to the more complex problem. Because on the end of year tests and all these other tests, the problems are of the complex nature. So you must get them to that level. You can't just expect to model the easy stuff and then they can immediately apply that to more complex problems. So, you know, we've been talking about the same problem, and now, since they've got the sort of the number sentence and the variables, we're now introducing the what? The fraction. We also have the opportunity, Robert planted an oak seedling. Is that really relevant to our problem? No, it's not. It could have been Johnny or Frankie or whatever. So we don't really need to spend any time on that. And now we get into the fraction. But now, since we've worked out those other things, they're less distracting. The student can focus a little bit more on fractions. Now, taking this to one more level of scaffolding, if I knew I was going to spend a decent amount of time on this problem with a fraction of 1 1/4 inches, what would have been a very strategic pre-skill to spend 5 to 10 minutes on before I got into these word problems? Table number 7. How to convert a fraction into a decimal. More importantly, I would have probably focused on what? 1 1/4 inches, maybe done some addition, maybe some manipulatives. So what you're doing is you're pre-teaching necessary skills for the student to solve the problem. Now, that's hard to do in current math books because the word problems are all over the place. So this does take some planning. Now, this is not dumbing down the curriculum. What this is breaking apart the curriculum, so to speak, and then putting them back together to build that kid's success. We have to remember, kids look at that problem right off the bat, half of them are going to stop right there and quit. So now it doesn't matter what you've done, you've already lost them. But by easing them in to the problem, you're providing them that sort of support to make them feel better to get to that. And I think math is something that lends itself to this because, you know, once you get into algebra, math problems are very complicated, multiple levels, multiple steps, lots of different things that are being applied there. Was there a question? I thought I saw a hand. No? Okay. Excellent. So everyone get the idea here? This is just an example which could have gone in all different directions depending on your kids and their needs. All right, so that was content scaffolding. The next level is task. This is what we do. Math books try to do this. Task scaffolding. This is sort of where we are specifying the steps in whatever it is we're trying to teach, or a strategy, all right? Where then the teacher will model these steps, verbalizing them to the students, think aloud, so critical. And if you're modeling something to the students in a think aloud, it's very important that they are not doing anything else but listening to what you're saying. Now, how can I scaffold something like this? So let's say I have a problem that has 4 steps in it. I'm going to think out loud these 4 steps. I want to make sure the students are listening to these 4 steps. What is a way that I can ensure my students are focusing on the 4 steps? Give them the 4 steps written down, and as they hear you say the steps, they should do what? Check off. Now, what you're doing there is you're taking something that's not really observable. Did they hear what I said? And putting it into an observable context behavior of, okay, they saw me do the 4 steps. Now from those 4 steps, I then get into having the students solve the problems. In math, you have the process, and you have the computation, and both are important. But a lot of times they're all happening at the same time, and sometimes we need to break that apart. Now, real quick, just because you've demonstrated it to the students multiple times does not mean they can do it independently, all right? How many of you watched the Olympics? And we watched a lot of flipping around, Michael Phelps and all this swimming, and we watched it all. How many are ready to get on a balance beam and try to do some of those flips? You are? Were you a gymnast? Were you a gymnast in a prior? No, okay. So just remember, there has to be a lot of checking and modeling going on there, that just because you've done it 3 or 4 times doesn't mean everyone has it. And then there's always the student who is not paying attention or not there, coming in late or whatever. So with task scaffolding, I'm going to sort of apply this to, again, general word problem solving. If you think about solving a word problem, in general, the first thing you obviously want the kids to do is what? Read it, and hopefully for understanding, possibly paraphrase in your own words. Now, when you solve a math problem, that's what you do. You read it and you're paraphrasing it. You may not be doing it overtly, but in your head you're sort of making sense of what you just read. Possibly visualize. Did any of you sort of visualize the tree growing in the first year versus the year after? You know, this is what good problem solvers do. Our kids are not good problem solvers. So we need to sort of teach these steps. And notice, are these really specific to math? No. This could apply to any type of situation. We need to model these and help prompt our kids to go through these procedures. So, with this word problem and similarities, there's a lot of similarities between comprehension of a reading passage and comprehension of a math problem. And then, therefore, we can sort of teach it in similar fashion. And, you know, looking at these: organization, irrelevant information, multiple formats, decoding of words is very difficult. Have you ever pre-taught vocabulary in math class? If you're in a co-teaching situation, that's a wonderful activity for your co-teacher to take a look at the vocabulary words coming up, pre-teach them. But we want the story problem to sort of come alive to the student. In other words, for that student to make sense of what it is. So there are a whole lot of learning strategies, and maybe some of you use these. If you go to this website here, there's a great little website here that talks about different strategies. And basically what these strategies are task scaffolding types of strategies that are trying to remind kids of what they're going to do. So in this one, RIDE, where you read, you identify, you determine, you enter the correct numbers. For this RAP-Q, you read the problem, you ask what the point is, and most of our kids will say, there is no point. Put the ideas into your own words, question your answer, and the equation. These are all strategies that are prompting the students in the tasks to solve the problems. Now, here is one of the biggest mistakes or challenges that teachers have when we teach strategies. What is a pre-skill for that first strategy, RIDE? The ability to read. All right? One strategy that we often hear in math books is guess and check. Okay? Now, I personally think it's misnamed, because guessing is just sort of, oh, guessing, there's 500 people in here. There's 10 people in here. Guessing and checking is really trying to get kids to do what? Estimate. And go in your math book or your standards and you look at how many estimation strategies are out there. What is the main pre-skill for estimation? What? Rounding or multiplication or addition. All right? So we have lots of strategies in place. You must remember that these strategies are prompting steps, but not necessarily pre-skills. I could teach my son who is in kindergarten ride. I could probably teach him to tell me what ride is back. Could he do that? Probably not, because he couldn't what? Read. All right, so it's very important we keep these. If estimation is the strategy you want the kids to use, we must make sure to teach estimation. Now, what do I mean by teaching a strategy? Well, if we take ride, for instance, and we sort of break a sequence into 4 lessons. Now, these lessons aren't necessarily one day. Maybe they're across a couple of days. But when I say teach a strategy or the steps in the strategy, you are literally teaching the kids what the steps are. Not doing them, but teaching them. So, ride, or the Frayer Model. This is the framework we're going to use. The first step in that, the teacher will literally teach it the first day. Model it, show the kids how to use it. Day 2, maybe we're just hoping our students will name that first strategy. We go on and continue to describe the steps and model it. Day 3, now we're on to the 3rd step, and then finally we're on to the 4th step. Generally what happens is we will teach a strategy at the same time we're trying to teach math. So we have kids trying to learn the steps plus the concept all at the same time. Some of these things need to be broken apart for kids, and that will allow then the kids to have a strategy to teach. All of your kids know the Frayer Model, right? Now they do. It took some time, right? They just didn't learn it automatically. But now they know it, so when you immediately start talking about math vocabulary, they already have a context of how that's going to look. And it took some time. Again, pay now or pay later. So now, what I want you to do, now we're back to Robert. I know you're tired of Robert planting the tree. Now I'm going to show you a task scaffold. I think in your handout part, where you've been writing, you should find a sheet that looks like this. I think it's labeled handout number 6. We may have 2 handout number 6 in there. That looks like this. This is both a task scaffold and a material. We haven't talked about material yet because I'm actually prompting the students. So with this, back to our Robert, what I want you to do is, okay, who or what is involved in this action? So let's see. Let's go back to the word problem here. No one's writing anything at this point. Let's see. Robert planted an oak seedling. It grew 10 inches the first year. Every year after it grew 1 1/4 inches. How tall was the oak tree after 9 years? So, who or what was involved in this seed? Okay. Well, we have Robert. He was planting a tree, an oak tree, and it was growing. So, who was involved in this? Robert. What was involved in the action? Planting and growing. Everybody write that down. Now, I'd like the lady at table 11 writing with the red pen and the cap to paraphrase who or what was involved in that word problem.
Robert, and he was planting and growing.
He was planting and the oak seedling was growing. Excellent. Now, let's just sort of back up. What did I do there? I modeled out loud the process. No one was writing down. After we came up with the answer, everybody then did what? Wrote the problem down. I then had a student do what? Paraphrase. Now, if I'm very strategic, I would have picked the student that I know sometimes has what? Trouble. All right? Now, what's another way I could have scaffolded that even more? Anyone? This is where I get excited about, because we're talking about teaching now. This is all about teaching. Well, another level of scaffolding was the sheet I gave you actually had that already written in there. So now I've talked about it, I've modeled it, we've given the answer, everybody looks there, and I've modeled writing it in there. So that's even another level of support, all right? That level, maybe you have given a sheet like this that's already filled out to your student who struggles the most. Now, another level of scaffolded support I could have been, which I didn't do, was I didn't write it up there. I made everybody what? Write Robert in a note. That in itself is a what? Could be a task for some kids. So maybe you have it already completed. All right, you see how the varying levels of scaffolding and support can go? So, how about my math vocabulary? Now, what are you going to want to key in the math vocabulary section here? What you really want to key is in first year, then years after, because isn't that the most critical attribute of this problem? We really want kids to recognize, because kids here can very easily just miss that. So now, math vocabulary, I'll put that in there. Okay, I'd like everyone to paraphrase it in your own words. Go ahead, write it on there. Third step, paraphrase the question of this problem. Now, we are spending a lot of time on one problem. But what we're spending time on is the essence of solving word problems, all right? Now, I'm not 100% sure about the Georgia tests. Are there open-ended questions? I would not be surprised if that isn't possibly coming down. There are a lot of states where they have open-ended math questions, where the kids have to write and explain everything, all right? So it's not relevant exactly, but what we're doing here is, this is full comprehension of a problem. Now, notice, we haven't even got to equation or the last three steps. This is heavily scaffolded to this point. All right? Yes?
Just a quick question. To paraphrase the question of the problem, do you mean including all the numbers or just...
I guess I should have provided a model. But I mean, I think at this point, what I would say, paraphrasing this question, they could have used the numbers, or maybe they didn't use the numbers. The big thing, I think, what you would want to see in this is that they're making the distinction that the tree grew a certain amount in the first year and then a certain amount in each year after.
Okay, so to make it true, they have the picture of the problem. What's
And if they drew
happening.
a picture, that's another place, have them draw a picture in there. That's excellent. Any of those things would work. Now, write an equation to obtain the solution. All right, we already did that. We already scaffolded it. See how this is task, it's scaffolding every single step of the problem to eventually, what we want them to do is get their answer and how they reasoned it out and then explain the solution. Now, any one of these could be modeled and spending 2 or 3 days just on the first two. Now, if you do 4 or 5 of these, then you go back and you start looking at the rest of these problems, all right? We very much teach beginning to end of a math problem. And what this is doing is it's taking the layers out. Now, I fully recognize the challenges that you have in your classroom of teaching 357 standards in 180 days of school. And of course, we can't do anything the first week or the week before winter break. You know, I understand all those types of variables. But what this is doing is it's teaching kids how to learn versus the content. Good problem solvers already do this. We just don't need step by step. We don't need a material scaffolding. We sort of do it automatically. All right? Any questions on sort of the process here? Scaffolding can go in many, many different directions depending on the students. But I do want to bring it back to the eventual point where we want the kids to be able to solve it on their own. It may take a long time to get there, but that's sort of what we're looking for. Yes, table 6.
Are you suggesting that perhaps we give this kind of guide for any problem, like after we do it in the classroom, perhaps give one problem for homework
Where they have to fill out
where they
that
have to
sheet?
fill this in to kind of give them the practice of scaffolding or the
Yes.
practice of solving a problem?
Yes.
Okay.
They may need you know, when you start really getting at attacking word problems, the first week may be spent on who or what is involved, and the homework is revolving around that. Then you slowly ease your way into those other things. And I think that's something that, again, it's a hard sell to make given all of the constraints we have. But if you're in a co-teaching situation, or you have kids going to extra math, connections, or what did you call your extended learning time, this is a strategy that can be applied. Now, what's nice here, could that not be possibly applied to a science, things in science or English language arts or any of those types of things? Where basically what we have to do with our kids is focus on getting them to be good problem solvers, because they're not. Sometimes in math, homework is not solving a math problem. It's breaking it down. Good. All right. Material scaffolding. And I'm going to give you a problem here in about 2 minutes where you're going to set up some scaffolding for me. But with material scaffolding, teachers do this a lot. Those posters we talked about, material scaffolding. Things that are cue sheets. I believe it was you that you said you have to give them homework where the solution's at the top of the problem, or the top of the page. It's the solution's there as another example. But what this is you're sort of helping the students through materials and scaffolding. This chart is a material scaffold. The steps are written there, but it's also a task scaffold as well. Scaffold them through there. They can use it as a reference to help reduce confusion, frustration. It gives prompts. And again, I am emphasizing this. Whatever the scaffold is, we have to eventually fade it out, because if we don't, they're stuck wanting to use that all the time. Concept maps. That's probably the most common sort of material scaffolding. And, you know, one of the things I think we need to recognize, you could have literally 18 bazillion concept maps, all right? It's better if you pick 4 or 5, and that's the structure of the concept map. The Frayer Model basically has a concept map built into it and how the information is presented. Fade over time so we don't have our kids looking up for the posters and so forth that are there. Here are some examples of cued sheets that you might come across, but basically here's one, never add the denominators, or I'm sorry, how to add fractions with different denominators so our kids don't give us 2/7 as the answer for this problem. And, you know, the steps are here in place, and it's cueing. Now, all these steps or all these cues all depend on the students. Some students are going to need more, some students are going to need less. But what you need to do is work your way to where they don't need the cues. So this is where you cover up the first step, they go to the second step, eventually to where they're solving the whole problem. Here's another example of functions. We were talking about functions earlier. Here's a sort of a concept map in a table format that takes the kids through the steps to determine if it's a function or not, with a key question being, do any of the ordered pairs have the same first coordinate? And, you know, that's getting into organizing information, presenting that in an organized fashion to help kids go through it. We do a lot of these. What we need to do is then begin to fade it away. Here's another. This is more of a concept map with exponents. What I like about this concept map is there's some vocabulary involved. This concept map may be changed by adding in what does an exponent mean, what is a definition of a base. We sort of model what it is. All that a concept map or material type of scaffolding do is trying to reorganize information. Here are some learning strategies taken off of the James Madison website, but this one is DIST. Does one side equal identify, see? Now they did a material scaffolding. Here are the steps, task scaffolding. They partnered it with sort of visual aids where they're telling the student, look, magnifying glass, look, steps, look. Now, one of the things we have to remember with this is prompting the kids on the steps. It does not necessarily teach what the distributive property is per se, but it teaches the steps. Here's another example for root, how you determine a square root. You have these in your handouts, right? Okay. And I know they're small, right? You can't see them. But again, this is prompting the students to take them through figuring out the square root of a problem. And all that this is are levels of support, cueing and prompting kids in how you do these things. I like this because it takes it from the abstract sort of down to not concrete, but pictures of concrete objects to sort of get at the fundamental of what a square root is. Now, there's lots of these things that are out there, but when we use these, we must use them strategically. We must, and then, if we're going to use them, have our students become less dependent upon them. So what I would like you to do, in your handout, you have an equation here, 2 equations. I want you to develop a scaffold for these steps. Now, I know some of you worked ahead, but I'm going to do something here a little bit different. There's multiple ways to solve this problem. Generally, initially, when we're talking about intersection of lines, how do we teach kids to solve this problem? Graphically, right? So this half of the room is going to set this problem up in a scaffold to solve it graphically. Okay? So you're going to go through the steps that a student would need and then come up with some scaffold. Where this half of the room, divided right down here, what's the other way that you're going to solve this? Where most of us would have immediately went to solve it is how? Algebraically, 2 equations, right? So you go ahead and solve it if you haven't already done it and sort of think of the steps. When you're doing this, what you have to keep in mind is how are your students looking at this problem? And where are they going to have trouble? So go ahead and we'll do this for about another 10 minutes, and then we'll share and have a break. Now, hello. How basic a question this is, and when you really start examining all of the steps that are involved in this, wow, this is actually what? A very complicated process. And that's really one of the biggest issues in math, is that this stuff gets complicated and requires vocabulary. I heard they were talking about vocabulary over there. Computation, algebraic expression. If you were graphing it, you've got to know XY axis, you've got to know point of origin, you've got to know how to draw the lines, how to get the points. I mean, we're talking about a ton of skills involved in a basic problem, which, by the way, is naked as far as there's no application. I just said find the line. All right, now generally slope-intercept is going to be taught when? 7th, 8th grade, in that range? Now graphing could be done a little bit earlier. Graphing, when you start solving it algebraically, you're talking about 8th grade or higher, okay? And the point of scaffolding, remember earlier I said scaffolding must take place prior to the classroom? One of the biggest challenges of scaffolding is it takes teacher planning, and I know the timing is involved. But in this, 2 purposes for doing this, I wanted you to start thinking in terms of scaffolding. But what you start to see is that this is a very, very intricate problem, even in the easiest aspect of just graphing it. And then when you get into solving it algebraically, you're basically having to do a lot of manipulation of the equation following principles of equality and all those, what you do to one side, you do to the other side, and then there was fractions in there, right? Would this been really a good problem to choose to do first? No, because there's fractions. So, you know, the answer, by the way, is 1, 4, okay? Now you can graph it. Now how many of you like graphing that to get an answer without graph paper? No, the most efficient way is to solve it simultaneously. Now, there's another way you can do it with just the slopes and determining one of the lines, and then you can use the slope of the other line to up, rise over run to figure out where it intersects. But the purpose of this was really to get you to take a look at what we teach kids and how complicated it is. Now, if we start talking about the various levels of scaffolding that could take place here, you know, basically, the way that I sort of approach a problem and how I'm going to break it down is I look at a problem, what's the first thing I'm going to do to this problem? And usually it's unrelated necessarily to math. I look at those two problems, which one of those equations looks easiest to do first? Okay, now that's unrelated to math. That's me making a sort of a self-regulated decision that this one is already in what? Slope-intercept form. Therefore, that's the easiest. Then the next one is to deal with that one that I conveniently did not put in slope-intercept form. So kids need to know what slope-intercept form is. They need to know what y equals mx plus b represents. Then they need to know how to graph. Now, those of you that were graphing, what was your first number that you put into y equals 5x minus 1? 0. I probably would have put 0 because 0 makes it very easy. See, that's another strategic approach. You don't necessarily want to put 1, 2, 3 or -1, -2, but we all sort of went about the same way. Now, for the graph, or for the solving it algebraically, what was the first thing that you did? Substitute. You took the y equals 5x and put it into the other one? Mm-hmm. No? You did. Is that what you did? There's a couple different ways. What were you going to do? Table 4.
I actually solved the second one for y.
For slope-intercept
form, and then using the transitive property of equality, set the two sides equal to each other and solve for x.
Yes. So there's a couple different ways you can do it, but the bottom line is kids need to know the slope-intercept form. So a scaffold for this is prior to getting into this, we review slope-intercept form, what it means. You may need to review graphing. All right, if you have a graphing calculator, a good way to introduce this is to graph it on the graphing calculator and let the kids see it, and then get into the why behind the graphing calculator. There's various different ways you could do this, but the bottom line is math is complicated. And someone up here at table 2 said, I'm writing out all these steps, and I need another piece of paper, okay? And you see where kids get into 8th grade and they're asked to solve this. This in by itself is unbelievably intimidating to them because of everything that they either don't know, haven't learned, or don't think they know. And just presenting that problem becomes a challenge. So as far as scaffolding goes with this, did anyone come up with any wonderful ideas? I know we were pretty much working on the math problem, but let's share if you happen to have one. Table number 8.
I don't know if it's wonderful, but I was just thinking if you had...
I'm sure it's going to be great.
If you had a class that, let's say, you know, moves pretty fastly or picks up on things easily, could you do this in reverse? Could you go through and just demonstrate how you work the problem and then have the class come up with the scaffolding? Have them tell you what steps that you did to answer the problem.
Yeah, if you have, I think that's a very good idea. You know, we're tending to focus on our lower kids that struggle. You know, ways to accelerate or enrich kids is to do activities like that where they're coming up. So I know how to solve that problem. I can do it. Okay, now come up with the steps that you would teach your mom or someone how to solve that problem. I think that's a good way to accelerate with kids there as well. Yeah. Anybody else have anything? You know, what I want you to take away from this is that a basic problem with this. Now notice, this was not in the context of a real world problem, all right? You know, if this was, you know, trying to make this real world problem, it could be very challenging and very distracting. And this is something that we need to ease our way into. And one easy is get out the fractions, put it in slope-intercept form already, start from there and work your way into that type of problem. Now, the graphing. You were doing graphing? A lot of steps there. And at table number 1, they were talking about, well, we're going to have to discuss the vocabulary of the quadrants, of XY axis, how you draw that. I mean, there was a lot of vocabulary that's included in this. And then what we're not even talking about is the straight computation that's involved with this, fractions. And anyway, all of these things need to be taken into account and coming up with ways to scaffold. And the bottom line is, you look at the problem, you look at the steps, what do my kids have to know, what do they need to know, what do I hope they know, and what do I need to fill in? And then you move forward for there. This might be a problem where some kids, where your whole first lesson or two is simply setting the problem up to the point where you're going to solve it algebraically, and that's all you do the first time, and then you slowly work your way in. But I think that's something that illustrates the point, and this is an 8th grade problem. Imagine what happens when you get into trigonometry and all those other much more higher math skills. Yes, table 7.
I think the most pressing question I have is, how does this impact the pacing guide? Because the first 6 weeks, you have to cover all of these different activities. Next 6 weeks is defined throughout the year, so.
Am I sweating now? Because I'm sweating now.
One of those you can't answer.
There's a reality check. And, a lot of what we know we need to do, sometimes the system makes it very challenging. And I think one of the things that we sort of have to come to grips with, we're not there yet in this program or in this country, simply moving everybody forward, we end up paying for later. So I don't really have an answer. I think some of the schools have this built-in extra time, building in other times that you're trying to fill in these gaps. But, pacing guides, I like the premise of pacing guides to kind of give teachers an idea of where you should be. One major sort of underlying fundamental problem with pacing guides is the assumption that what? Everyone's progressing at the same rate. So I really think schools have to go back to the data, look at where their weaknesses are, adjust for the pacing guides as necessary. But bottom line is, pacing guides are good in theory, but we're dealing with the reality of the kids, and it's something that you have to come to grips. There's no absolutes. Table 4.
I think one of the things that's important to keep in mind is when you're writing out a scaffolding, you don't want to include within the scaffold of how to solve this problem all the scaffolding that would go with the prerequisite skill, or becomes much too wordy. I mean, you have to assume at this point that a child knows how to graph a line using slope and y-intercept, or by some means. If they don't, that's another whole scaffold.
Yes, I think that's a very good point in that, initially you sort of, okay, up till this point, the standards and the curriculum should have gotten kids at this level. So here's the initial process. Now, what am I going to do with kids that can't graph, kids that can't do this? That's sort of another issue. It's got to be addressed, because if they can't do those things, they're going to have great difficulty doing what we want to do. But I think she makes a very good point that sometimes our scaffolds can go on and on and on forever, that we need to focus on what we need to do. And I think that's why the standards in Georgia being changed are eventually going to lead kids, that when you get kids, you're going to know this is where they are, and then you can move forward. But I think formative assessment, progress monitoring, those types of data will sort of give you an idea of the gaps that kids are missing and how you fill that in. But I think that's a very good point. All right, any other questions on this? Comments?
I have a question, but it's not about this.
Okay. Is it for me?
Well, just something to put out there for people to ponder, perhaps. Why is the assessment given so early in the year? There's almost 6 weeks of instruction after the test. Why?
My take on that is that they want to get that data back to you as quickly as possible. Interesting enough, South Carolina, they gave their assessment the second to last week of school. Wow. Up until this year. They're now moving it into March so that data can get back to the teachers, kind of like here in Georgia. And most states are like that. I know it's a balancing effect. Yeah, I guess I don't really know the answer other than I think they want to try to get the data back to you as quickly as possible so that you can sort of fill in the gaps in those last 6 weeks. Okay. All right, we're going to go ahead and have a break right now, and 15 minutes, we'll get back started in the last session.